Hello guys, we are back with another interview problem, that is replace elements with the greatest element on the right. Okay, given an array of numbers, okay, write a function to replace each element of the array with the greatest element present to its right side. Okay, replace the last element with the minus one. Okay, so let's take a couple of examples. So let's say if this is a given array, so we have 4, 5, 2, 25, 13, 16, and 8. Okay, so uh, if you look at 4, the greatest element on the right is 25, so 25. And then for 5 it is also 25, and for 2 it is 25, and for 25 itself the greatest element on the right is 16, so 16. And then for 13 it's also 16. So for 16 there's only one element on the right, so that's gonna be the greatest element. So 8, and there is nothing, no element on the right of 8 because it's the last element, so replace it with minus 1. So this is our output. And this is another example. So if we see here, the last element itself, the greatest element in the entire array, so the last element will be replaced by minus 1, and all other elements will be replaced by 38. So let's see how we'll solve this. um, so let's say this is our array. Okay, so brute force approach would be to iterate the array from left to right and compare each element with all the other elements in the array and find the maximum one and replace it. Okay, so for example, if you take 4, compare 4 with all other elements to the right and replace it with the maximum one, so it's going to be 25, right? Similarly, do it for 5, compare it with all the elements to the right, so it's going to be 25. When you'll do it for 13, so compare it with 16 and 18, so 16. Okay, so this is a brute force. So clearly we can see that there are two nested loops, and the complexity would be O of n square. So can we solve this in O of n? And the answer is yes. So idea is to iterate the approach from right to left, okay, in this direction. And let's say we have a variable called max and initialize it to minus 1. This variable going to store the maximum value which we have seen during this iteration. Okay, so let's start. So initially it's minus 1. So for 8 we'll put minus 1. That's what the max value is. And once we put, we'll compare 8 and minus 1. Okay, and store it in a max. So max will be 8. Okay, now when at 16 the max value is 8, so store 8. And once you put 8, now compare 16 and 8. Okay, so now the max is 16. Okay, so when here the max is 16, so put 16 and compare 16 and 13. So 16 is still greater, so we'll not change the max value. Now once here, put 16, right, and compare 25 and 16. So 25 is greater, so max becomes 25. Now when doing it for 2, the max is 25, and compare 25 with 2, so the max stays to 25. Similarly for 5 and 4. Okay, so this is going to be our final output. So let's go back to the problem. So let's read the approach. Naive solution would be to use nested loops, compare each element of the array with all the elements of the array to its right and replace it with the maximum one. Okay, the last element will be minus 1. So the time complexity is n square. Better solution, initialize max to minus 1. Now iterate the array from right to left and replace the current element with the max element. Now check if max is less than the current element. If yes, replace the max with the current element. Okay, once the iteration is done, return the updated array. Okay, so This is our function. It's taking integer array as input, initialize the max to -1, and now we are iterating from right to left, okay, in this direction. Get the value of current index, right? And at the current index, store the max value and check if max value, whichever is greater, the max value and the current index value, and store it in a max. Okay, so once we are done with this, our array is updated, we'll return that. Okay, so yeah, this is how we're going to solve this problem, and we can mark this problem as completed. And visit our website tutorialhorizon.com for more interview problems. We'll see you guys in the next video. Bye bye.